Evolve is a tool that supports incremental and distributed development of complex software systems. It provides architectural primitives for defining change in addition to those for system creation. Here is an initial system with a set of components defined using a UML-based component notation. This system was developed by CompSoft. This is a simple single-lane bridge simulation. It consists of three primitive components, a car, a controller and a display. Also present is the composite component SLB, which composes these into a running system. Each primitive component is implemented by a Java class. We can execute the system as follows. We can see at this point that the system clearly has a functional deficiency. The original system is distributed to Biggersoft, who extends it to deal with two cars in each direction. Using the original car component, Biggersoft builds a two-car component using composition. They then extend the overall system using the resemblance architectural construct. We now show the steps that Biggersoft took to create the extension. Resemblance is a generalization of structural inheritance allowing a component to be extended. Using resemblance, any part of the inherited structure may be added to, deleted or replaced. Note that although Biggersoft have made delta changes to the inherited structure, it can work with the fully expanded structure at all times. Note also that Biggersoft have not touched the component definitions or code developed by CompSoft when making their extension. Error checking the system shows that there are no errors in the extension, so we can now run the program. We can see that Biggersoft has successfully introduced two cars. However, the system still has the original problem of the bridge being unsafe. Meanwhile, another company, Bettersoft, has decided to independently extend the original CompSoft system to make the bridge safe. We will now demonstrate the steps that Bettersoft took to achieve this. First, we locate the original controller. We then evolve it using a combination of replacement and resemblance, which we provide in a combined construct called evolution. We can now set the implementation of the evolved component to be the new safe controller class. The effect of this is to globally substitute the new controller and its implementation for the old one. Executing the system shows that the bridge is now safe for both cars. Lastly, MegaMergerSoft wants a safe system with two cars. It does this by defining a new extension that depends on the two previous extensions. This will automatically combine those extensions and no further work is required. Structural conflicts for the entire system can then be detected by a checking process, which examines each of the different extensions in turn. In this case there are no conflicts, so we are free to run the system, which features two cars and a safe bridge. Note that the combining of the extensions happened automatically. If we wish to look at the overall system, we can display it from MegaMergerSoft's perspective automatically. If the two extensions did in fact conflict, or we wish to extend further, we could use evolution to adjust or correct the structure. The architecture definition language also supports dynamic component creation. Here is a multi-car extension using car factories, which allows n cars. Again, we have used resemblance to define the multiple car bridge from the single lane bridge, as you can see from the delta markings. Executing the system shows that multiple cars are provided, but the bridge is not fair. We can combine our multi-car extension with a fair bridged extension to produce a system which provides fair access. As the architectural extensions are kept as deltas, changing the dependencies will change the system and apply those deltas to the new base architecture. Running the system, we see that the bridge is now fair. In summary, Evolve provides intrinsic definition of evolution in an architecture description language. This allows distributed development equivalent to branching in a version control system. The same concepts also support combining independently developed extensions back into a single model and repairing any architectural conflicts or deficiencies that may result.